In this video, I wanted to describe how we use inverse functions to solve equations. And obviously, one important thing to know when we're working with mathematical functions is how does it work in an equation if I'm trying to do a real problem, usually that results in some form of an equation, how do I solve it? Like, for example, I want to know what the answer to an equation such as 2x plus 4 equals 7. I want to know what's the goal. How do I solve for x? How do I solve for x? How do I get rid of the stuff? Kind of the same idea. Like, for example, say I have sine x equal 1/2. How do I solve for x? What's the answer? How do I get rid of sine? And in the last couple videos, when we were talking about the purposes, that is always the point of an inverse function, is to solve for it. But like when I'm looking at this equation, what I'm trying to know is what x value creates 1/2 in a sine. Like, what number would suffice to have a sine value of 1/2. And if I'm thinking about how this works with the unit circle, sine of t always makes the y value. So what I would be thinking about is, well, what t value produces a y of 1/2? Where is y 1/2 on the unit circle? So I'd naturally be thinking about, when I'm looking at those points, which one has a y of 1/2, and I could think about, okay, well, it'd be there. But that's exactly what an inverse trig function does, is if I take the inverse trig of both sides, what that would give me is x is equal to the arcsine of 1/2. And now what this means is, well, input is 1/2, output is the y value. Output is going to be the location which t value has the y value of 1/2, which in this case, well, the first point on the unit circle has a y value of 1/2, which is pi over 6, or 30 degrees. So what this leads me to is one potential solution based on evaluating. Or I could use a calculator to figure this out, because your calculator has complete ability to do any inverse trig function, assuming you're within the domain. And it would give me 30 degrees or pi over 6. Again, as I said before, you could answer it in either way. Now, typically, when you're solving an equation, you want to answer in radian mode because it does not tell you to answer it in. It's kind of like if you're trying to solve an equation in meters and you give your answer as 3 miles. Well, it's not the right type of units. Typically, you want to answer it as appropriately as possible. But at the end of the day, it doesn't matter, because it's equal. But anyways, the point is we could solve this equation, and then if I plug it back in, it should make sense. Sine of pi over 6, yes, is 1/2 if we reference the unit circle. But actually, another thing about trigonometric equations is this is not the whole story. This is only one solution. Now, going back to looking at the alternative solutions, we're going to talk about this when we get into analytic trigonometry on the next. Sorry, that's a tough thing to say. Try to say that 5 times fast. Analytic trigonometry, I can't do it. I challenge you to do it. Anyways, when we're trying to solve equations, we're going to come back to this, but that's the basic idea of how inverses help us with equations, and they help us find a primary solution. And another thing, I don't know if you were wondering, is what about the other 4? Are there inverse functions to those? Well, of course there is for tangent, because we can see it right there on our calculator. But I digress. Yes, there are. I think I'm not going to really bother to get into them too much. But if you do want to know what about the arctangent, it's taken by restricting our domain to one of those particular noodles of the tangent, negative pi over 2 to pi over 2, non-inclusive because it's undefined at those points, and it has actually a range of all real numbers. So if we're going to do the arctan and we wanted to know, well, what's the valid domain and range? The domain of arctangent will be all real numbers, because remember they're swapped, and the range will be negative pi over 2 to pi over 2. So it's actually exactly the same as sine for the range. It's just not inclusive of the boundary points, and a lot of similarities. But that is enough on inverse functions for this chapter. And as I wrap this up, I wanted to mention about our exam next week. We will actually not be starting chapter 5. I feel as though this is a lot of information. I'm going to save the beginning of chapter 5 for the next test. and we're actually going to cut it off right here. I am currently working on a practice exam for y'all, which will be up and ready by Monday. But anyways, I hope you all are doing well. This will wrap up this topic.